Hello everyone, welcome to Java Backend series. As part of this series, we are talking about the very first module, and this module we are talking about the object-oriented programming. So the object-oriented programming module agenda is we will talk about the object-oriented programming. What is object-oriented programming? Why object-oriented programming is required? What is the difference between object-oriented programming versus procedural language? We will also talk about some four pillar of object-oriented programming. We will talk about some real-world example. We will also see how object-oriented programming uses in enterprise applications. We may see some kind of coding demo, then we will discuss about the interview question summary, and then we'll move to next module, that is classes, object, and constructor. So from next module we will do coding practice. And before moving to next module, let's discuss about the basic concept for object-oriented programming and why Java adopt this object-oriented programming, right? So once you talk about the object-oriented programming, the very first thing, uh, all things comes around the objects. That's how we are saying it is object-oriented programming. So if you see this particular example where we have blueprint you can think as a class in Java, and the object as a house you can treat as a object, and then we have some attributes and then some behaviors or methods, right? So let's start with the blueprint. So if you talk about the real world example in as shown in the slide, so before having a blueprint you can't construct a house, right? Why blueprint is required? So think about, we are developing as a developer, as a real estate developer, we are developing a housing plan, right? And that housing plan needs lots of approval, right? The approval is like from the development authority of that city, that area. We may also require some kind of rules and regulations, means what are the road size in that housing plan, is there any park available or not, how many houses you can create. So all those things come in that plan, right? And each and every house have their own blueprint. So own blueprint means, is this 3 story, 4 story, 2 story house, and what is the height, what is the length, what is the width of that house, right? So there are lots of rules and regulation in housing plan. So direct jumping to creation or house development, we should first perform the blueprint, and that blueprint need approval. So once we have approved blueprint, then we have kind of confirmation, means whatever we are generating as an object from this blueprint also follow the rules and compliances, because that blueprint is compliant, right? So that is the importance of blueprint or as a class before generating a object. Okay. And once you have the object, then every object have their own attributes. So if you talk about the particular object as shown in the slide as a house, those this house have their own attribute like windows, doors, colors, area, and they have their own behaviors or methods like open door, closed door, calculate area, right? If you talk about some other objects like any animal, right? So animal, how you will recognize that is an animal? So they have their own attribute like four legs, one tail, and they have their, if you talk about the dog as an animal, so dog have four legs, one tail, right? They have some other attributes, and behavior is like they are barking, right? So they are friendly, right? So each attribute and behavior also help us to define the type of that object. Okay. So I hope this concept is pretty much clear. If still there is anything you want to discuss, just do comment in my video. I will try to answer each of your comments. Okay. Now move to next next topic, means why object oriented programming, why it is so popular, what is the benefit of object oriented programming, right? So this if we do the comparison between the procedural programming versus object-oriented programming, so it helps us to identify the pros and cons of both languages. So if you talk about the procedural language is like the C, COBOL, right? And they uses based on the function creation, function calling, function to function, right? If anybody is aware of C language, so he should know means how to write a C programs, right? There are too much functions which relates each other and create a software program flow, right? So the basically the idea is like the functional procedural programming always a top to down approach, while the object oriented programming is bottom up approach. So what I mean to say, if you talk about the top to down approach, this approach talks about how to do things first. So if you take a very basic example for a banking applications, right? So as a procedural programmer, we have to think like that, what kind of operations we have to perform as a banking application, so how we can perform these operations. So these operations comes as a functions. So like if we have very basic banking applications, and we have very basic four examples, four functions, right? One is like login, second one is your withdraw money, third one is your deposit money, and if all these happen, then you should also have the functionality to log out from your banking applications, right? So if you are a procedural programmer, so you should like think like that, I will create a login function, then I will create a withdraw function, then I will create a deposit function, and then I will create a logout function. So this is basically top to down, we just thinking how to do the things. But once you talk about the object oriented programming, this is basically a bottom up approach. So before thinking how to do things, we should think about who is involved in that particular software applications, what are the parties involved in that software application. So that is the bottom layer, right? So if you know what are the parties, then you should able to recognize which party do what, right? So for example, if you talk about the same banking application, so we have very basic parties like customers, right? The bank account or banks. So and then we have some kind of transactions, right? So customer is like your bottom thing, right? It comes at last. So one, until you have the customer, you can't do anything. Before customer you can't do anything, right? That customer have their own attributes, the customer have their attributes like the customer name, the customer age, right? The customer income, right? The customer address. If you talk about the bank as a object, then bank have their banking account, bank address, how many customers are in their bank, right? So once we close the bottom layer, then we think about the operations, means who perform what. So customer, what customer can do, customer can go to bank and open an account, right? And then they have their own user id password, then they can log in, right? In the same way, what bank will do, bank will, when bank will hold the money deposited by the customers, and they can also maintain the balance, right? If a customer deposit a money, customer withdraw a money, so all those things is maintained by the bank. So basically these are the basic difference with a very basic example. There are lots of complex thing happening in real time, but I think this will give you the idea, the difference between the procedural language versus object oriented language. So it will also help me to create a matrix, and where I can decide what programming language I can choose in which kind of problems, right? So object oriented programming focused on the object that contains data and behavior, data like the bank balance, right? And behavior like deposit or withdraw money, correct? They bundled the data and functions in a same class. So data like, you can say, the name of the customer, the address of that customer, the salary of the customer, right, the income range of that customer. Those are the data. And function is like customer can deposit money, customer can log in into the banking application, customer can withdraw amount from the banking applications, right? So here you can see the reusability is very high. We will also discuss about some advanced reusability feature like inheritance, polymorphism, encapsulation in further classes. But for now we can think about the reusability is like once the object is created, we will separate out the behavior of that object separately from customer to bank, and that can be reusable again and again, right? So I have a customer class, and that customer class have the n number of customer objects, right? So if you see the customer class as a customer class, but if a bank have thousand of customers, so the same class can be reused to create those thousand customer objects. So this gives me the high reusability within the system. And it is also help us to maintain and update that particular thing very well, because we reduce the scope. So once we think about the object level or bottom up approach, we reduce the scope, means the scope related to customer reside in the customer class, the scope related to the bank reside in the bank class, and it will also help you to update the small portion of that particular functionality, right? So let's assume if you have to update the address of a particular customer, you just need to search that customer object and update the address, like the city. If that customer moved to another city, you just need to update that city name, state, right? So it reduce the particular functionality and make that software easy to maintain, right? In the same way, it is also help us to scale the system. So as we reduce the work, we can scale it. So scale it means we can decide where the scale is required. So if you in a real world, if you think about the number of bank always less compared to number of customers, right? We can't say if we have a thousand customer in a city, we have the thousand branch of the same bank in that city, right? So this is not the case anyway, right? So one bank can hold the thousand number of customers. So we can decide where the scale is required. So if this particular example, you can clearly see the scale required at the customer end, not the bank end, right? Because the number of bank are limited while the customers are increasing day by day, right? So this will also help us to decide the scale factor on a particular functionality object or the bottom line, correct? And it will also help us to secure the data, right? So we will discuss about the encapsulation in next phase, but the security in the sense how you can secure the bank account number, right? Because we have bank is separate, customer is separate. So and the customer, if we have a n number of customer objects, so the customer one can't see the bank account number of customer 2, right? So that is the security thing, the data hiding thing, right? So those objects help us to secure and hide the data from other object, right? As a banking application, I don't want to share my bank account to someone else, right? Because that is a security feature, right? I don't want to share my banking password to someone else. So I am maintaining my own object within the system. So I am maintaining my own account number, my own user ID password within my object. So that's how it will also help me to secure my uh, data with other objects, right? So I hope this will also clear your understanding about the object oriented programming, their multiple dimensions, and why it is better than procedural programming. Okay, in any case, if you have any question, just do comment on my video. I will reply to your comments. Now move to four pillars of object-oriented programming, that is encapsulations, inheritance, polymorphism, and abstractions. These are the most important concept to understand the object-oriented programming. We will have a detailed video for each concept in later series, where we will discuss each and every topic with details and coding examples. For now, let's discuss these four concepts at very high level. So once we talk about the encapsulation, so encapsulations help us to binding data with variables and methods to a single unit known as class, right? So this particular thing we already saw in our house examples, where you can see the blueprint as a class and object as a house, right? And this class is having the variables like window, door, uh, and the color of that house, and the functions or method you can assume like open door, close door, calculate area, right? So all these things we have combined and put as a single unit known as a class. So that particular combination of data variable plus their methods in a single unit in a class known as a encapsulations. So benefit we will discuss in the later videos. I think that is the better place where we will have some coding example, and we will demo uh, the part of hiding data and how we can provide the control access of uh, uh, data security, right? Now move to inheritance. Inheritance, as you uh, have idea from the name, right? Inheritance, it will inherit somewhere, right? So basically, this idea comes from the parent-child relationships. So a child always inherits some kind of properties from the parent. In the same way, we implement inheritance as a parent to child relations, uh, where child can get some attributes, some behavior from the parents, and we will discuss this as well in detail with coding examples in later classes. Now, once you talk about the polymorphism, this is one of the important and confusing topics sometimes, and we will discuss this as well in detail, right? So for now, you can say the ability of an object to make many forms, and it allow us to perform a single action in different ways. So the idea is like, how can we utilize a method in different ways, a same method in a different ways to perform different activities. So that is the idea behind the polymorphisms. We have two type of polymorphisms, like runtime polymorphism or compile time polymorphism. We will discuss these thing with coding example in later classes. And was one of the last attribute, you can see the abstractions, right? So abstraction is basically hiding the complex thing with the end users. So there is a very popular example, like if you are driving a car, so you don't know how car engine works, right? You just need to know how gear shifted, how clutch is working, how you have to give the accelerator to that car, or how you have to handle the steering, right? So only these basic thing you have to know to uh, drive a car, right? But you don't know how piston is running inside the engine, how spark plugs is sparking and generate the force within the engine, right? So those all complex engineering work uh, not required, right? So that is the complex thing we can hide from the user, and they just enjoy the ride without knowing too much complexity. So the same concept we will provide as abstractions uh, in later videos, and we will do some good examples, good practice examples, some real-time scenarios where we can understand why these four concepts are so important to implement a good object-oriented programming softwares, right? Now, once you talk about the real-world examples, so here you can see I have mentioned six type of different type of examples, right? Where you can see everywhere. Uh, object-oriented programming is applicable, right? So once you talk about the banking system, so you can assume object as account, customer, loan, and behavior is like a deposit, withdraw, calculate interest, transfers, right? Transfer funds. We discussed this thing earlier, right? And in the same way, if you have the car, right? So car have a car engine and wheel kinds of objects, and behavior is like start, stop, accelerate, brake, and turns. In the same, if you go with the e-commerce domain, then we have a different type of objects like product, cart, order, user, right? And the behavior is like a user can search a product, add to the cart, then check out and track the order, right? So those all kind of behaviors comes in the picture, right? In the same way, if you talk about some WhatsApp kind of applications or chat applications, then objects could be your users messages, right? Chat groups, and the behavior is like send message, delete messages, create groups, add participants. So basically behavior is like the actions, what are the actions you are performing within that software, right? In the same way, if you talk about the Netflix, you have a user, movie as playlist as kind of objects. So and behavior is like your play, pause, recommended, a movie list, right? And recommendation kind of activity, add to your list, right? And if you talk about the some healthcare domain, then we have patient, doctor appointments kind of objects present, and behavior is like your book appointment, generate bill, discharge. So you can see the object oriented programming play a very important role to design a good, maintainable, scalable, reusable kind of systems, right, in everywhere. And as we move forward within our Java backend series, we will try to relate all these different domain with good coding examples, right? Now once we switch to some kind of enterprise applications, so enterprise applications is maintaining a flow of the software, right? So basically I am trying to present one of the basic software flow where the business requirement come first, then we have to design the models, or you can say domain objects, correct? Identify the real world entities and model and them as a classes, and then we will implement some kind of behaviors, some kind of actions, right? And then we have to persist that data in some of the databases to maintain the integrity within the data, right? And then we deliver those applications, uh, combine in some kind of deployable jars and put somewhere on the cloud or may some servers, and that software may applicable for end users. So this is the like basic life cycle for enterprise applications. And you can assume, you can take that particular house example, right? So as a business requirement, a housing plan can come, right? Or let's say a developer, real estate developer is planning to develop a housing society, right? So he will generate some business requirement, means this is the land, this is the size of land, these kind of facilities we have to provide within this housing society. Then the architect may come and create some kind of blueprint, right? And that blueprint they can go for the approval with the authorities, maybe their cities development authorities. And once all the approvals comes, then they will try to create the real objects, building the housing plans, means how many numbers are houses within that society, is there any temple, is there any parks, is there, how many roads are there, what are the width of and length of the roads, right? So all those comes as a part of your blueprints, and then that blueprints converted to their uh, respective objects, right? And then that objects have their own behaviors, means if you talk about the park, then how many numbers of trees are there, how much greenery you can put in that park, right? And if you talk about the house objects, so what are the size of houses, how many types of houses, mean 3 bhk bungalow, 2 bhk, 4 bhk, right? All those types can exist. So all those kind of attributes you can present. And now you have like behaviors like how many uh, parking areas in that particular object, right? And how to uh, uh, open the door, close the door, calculate the area, right? Calculate based on the area you can calculate the price of that particular house, right? So all those things comes as a your behaviors. And then you will add some databases, persist that data, means who purchased that house, who is the owner of that house, how much payment is completed for that particular house payment, right? So all those things you can persist in some kind of database. And at last you have to provide some security scalable solutions, right? Because the thing is, once you start anything, it will always scale, right? uh, People's coming there, they like the project, maybe the phase 1, phase 2, and further phases launch within that project, housing project. So the scalability you can relate at that way, right? In this slide we have like example of banking applications, right? So banking applications have their classes like account, customers, and transactions. And customer have different attributes like customer name, their date of birth, amount type, right? And the account number. In the same way, account objects have different type of object like saving account, current account, loan account, right? So now you can relate all those things, how this object oriented programming help us to generate a bottom up approach to design a system in a manner that can be scalable or reusable kind of facilities, right? So some of the basic interview questions as part of this slide we may have, what is object-oriented programming, right? So we already discussed what is object-oriented programming, how blueprint convert to object, and object have their own attributes, their own behaviors, right? And how classes relate to blueprint, right? So all those comes in object-oriented programming concept. Then why it is required, what are the four pillars. So this is actually very important topic. So I don't want to add details for these four pillars in this video, because it will, then the video will be like too long. So I am planning to create a separate video for each of the concept of encapsulations, inheritance, polymorphisms, and abstractions separately. And then we have a high level discussions about these encapsulations, inheritance, polymorphisms, and abstractions. Later we will or discuss about these concept with coding examples. Now we have also later on we will see the once we talk about the abstraction, then we will see about the difference between the abstract class and interface uh, uh, in that particular concept discussions. Now uh, can we achieve, it is like very important thing, means can we achieve 100% abstraction in Java or not? So once we discuss the abstraction, then we will try to answer this question as well. And we also see the real world example, like each and every domain we have object oriented programming. Like if you talk about the healthcare domain, like hospitals, if you talk about the banking domain, right? So we already seen that everywhere we have the object oriented programming, right? Now if you talk about the summary, so what we have discussed till now, means we have discussed about the object oriented programming. We discussed about the four pillars of object oriented programming. We have also seen the benefits of object oriented programming, like how we can achieve the reusability, maintainability, right, scalability in the systems. And then we also seen some kind of real world example, like your banking use case, e-commerce use case, hospital systems, right? How we can consider the different objects with different attributes and different behaviors, and how we can uh, create a software flow within that domain, right? So yeah, now thank you for watching this particular my first video on Java backend series. uh, if you like, please do subscribe my channel and try to comment it. If you have any suggestion, then do comment. I will try to improve and add more concept uh, here, right? Thank you once again.